Yes, hi guys. So today I'm taking the second lecture series, okay, of the same topic, order and degree, okay, order and degree of a differential equation. This is further discussion. I've taken some more questions based on the same topic, order and degree of a differential equation. Alright, that are just defined. I have already defined in lecture 1 series, okay, in which I defined that what is differential equation, how it is to be defined, okay, what is definition of differential equation. Now, yes, again I'll repeat it, but before that, I have taken these questions which are a bit complicated one than the previous lecture series, okay, than the lecture series 1. Now in this lecture series, I've taken some difficult questions which are in form of radical sign, in form of fractions, okay, as I did tell you that a differential equation, okay, is having a degree. If we have to find the degree of a differential equation, then it must be without fraction, without radical signs. If it is free from radical signs, free from fractions, then we find out what is the degree of a differential equation. The degree is the power or exponent of the highest order degree differential coefficient in that equation. If the differential equation is having some differential coefficient, undoubtedly will have at least one differential coefficient is there. Differential or derivative of a dependent variable with respect to independent variable is given there. Okay. Now, if this differential equation is having at least one term of differential coefficient or derivative of a dependent variable, then it is a differential equation. This is the definition as I defined in the previous lecture series. Now, but in this case, when this equation, differential equation, is free from radicals and free from fractions, radicals means square root, cube root, nth root, etc. Okay, so free from roots or 1.2 power, 1.3 power, 1.4 power, etc. That means radicals 3 by 2, 5 by 2, etc. etc. These are radical signs. Okay, if there are radical signs, and then this is not a differential equation, so we have to make free differential equation. I mean, that is a differential equation, but we have to, if we have to find out the degree of a differential equation, then we have to make the differential equation free from these radicals, okay, or free from the fractions as well. Then we find out what is the order of that, or sorry, what is the power of the order of a differential equation, highest order of a differential equation. So the degree is the power of the highest derivative found in a differential equation. Okay, that power of that highest derivative is known as degree. That I have defined already. So again, let me define. And then in case of engineering classes, okay, we discuss about there is a partial differential equations also. Okay, there is a topic, partial derivatives, partial differential equations. If it is normal differential equations we are talking about, if there is even a single term, single derivative is partial derivative, partial differential coefficient, okay, or partial differential of a dependent variable with respect to another variable, one or two variables, okay, there is two variables or a single variable it may be, but if a function or if a variable, dependent variable or a function is having partial differential coefficient with respect to another independent variable, or two independent variables, one independent variable, three independent variables. But in engineering we will define what is two independent variables. Okay, so with respect to two independent variables, then that equation is known as partial differential equation. So partial differential equations are also defined. That is not topic of the today. Okay, that are defined. I've taken one question here. This is the ninth question. The ninth question is partial differential equation. Why? Because it is having the derivative in partial differential equation form. So del square by upon del x square is equal to a square into del by del x. So this is the partial differential equation. So this is having two partial differential derivative. One is second order and other is first order. So if any differential equation which is having even a single partial derivative of a dependent variable with respect to independent variable, one independent variable with respect to two independent variables, like del s upon del x, del s upon del y. In this way we are defined. S is a function here Okay, it is differentiated with respect to x with respect to y, maybe different with respect to z as well. So there may be three dimensions also. So only we will talk about that is partial differential equation. Okay, so that is we will discuss in case of when I take after this complete a differential equation, normal differential equation. Okay, this is we are talking about normal differential equations. In this case, we are differentiating the function normally, okay, with respect to x variable, with respect to y variable. Okay, if it is independent variable, if x is independent variable or y may be independent variable, then other variable u or v may be dependent variable. Here we are taking y as dependent variable, x as independent variable. Any differential equation. What is differential equation? Normal differential equation. A differential equation which is having dependent variables, independent variables, and derivatives or differential coefficients of dependent variable with respect to independent variables are known as differential equations. Okay, so that we have defined already. Differential equation is defined like this. Okay, so these are the differential equations. We have to find out order and derivative. So let me again define that what is order and derivative. Order is, as I defined lecture number 1, what is order? Order of a differential equation. Differential equation, okay, is the order of the highest derivative, order of the highest order derivative, highest order derivative found in a differential equation, in a differential equation is known as order of that differential equation is known as order of that differential equation of that, let me take differential equation. Okay, differential equation. So order is the order of the highest derivative or highest order derivative found in a differential equation. That order is known as order of the differential equation. Now degree, we defined what is the, this is order about, and what is degree of a differential equation. Degree is the power or exponent of a highest derivative, highest order of a highest order derivative found in a differential equation, found in a differential equation. Okay, this is differential equation. So this is power or exponent of a highest order derivative found in a differential equation. So that order we have to find out after making it free from, after it is free from, after it is free from radicals, let me take capital radicals and fractions. When the differential equation is free from radicals and free from fractions, after that we find out that what is the power of the highest order derivative. This we have defined in the first lecture series, but at the moment I'm taking only these radicals, fractions, etc. Those equations which are involving fractions, radicals, etc. I'll define that this is radical found here, or second order radical, or what is the radical means. Okay, so third radical or second order radical means 1.2 power, 1.3 power, or 2 by 4, 2 by 3, 3 by 2, etc. etc. All these are radical signs. All these, if the equations are free from radicals and fractions, then we find out what the degree or power of that derivative. I'll just define that how this is free from the radicals or free from fractions. Now the order, degree of that equation is calculated. So degree is the power or exponent of a highest order derivative found in a differential equation after it is free from radicals and fractions. Simple. This is the definition of degree. Order is the simple. highest order derivative found in a differential equation is the order of that differential equation. Order. Okay, so this is the definition. This is the definition of the two, order and degree, which we have already defined in lecture 1 series. Okay. Now let me take these questions. Again, these questions are taken from students' queries because in the class we have found number of queries from the student side that I always define here. On the request of these students, sometimes online students have also asked me some questions, so they are called here with the order and degree of this equation. So simple questions. Now let me take question number 1 that I'll define. Okay, so first question, find the order and degree of the following differential equations. These 26 questions are taken here. Here are the other queries from the student side. Okay, so that let me take first question with the order of the first equation. This is twice x minus twice y plus 5 into dx is equal to x minus y plus 3 into dy. Okay, into dy. Now we have to make it a differential equation. If I divide this dy by dx, so we can take here dy dx. What I've done, I've divided by dx here, or divide both these sides by dx. We have taken dy by dx into x minus y plus 3 is equal to twice x minus 2y plus 5. Okay, this I have kept here in the right hand side. Left hand side I have taken to right hand side, and right hand side to left hand side. This is dy by dx into x minus y plus 3 is equal to this value. Or this is the differential equation for d by dx equal to, we can take this is twice x minus 2y plus 5 divided by x minus y plus 3. This is d by dx value. Or we can just write this. This is the differential equation. Now this differential equation is of order 1, degree 1. Let me write here what is the order and the degree of this equation. Now this equation is free from powers, radicals, etc. Or there are no radical here, only free from a fraction here, because this dy upon dx are taken to this side. So this is now order is 1 only because this is first order derivative, order 1. Degree is also 1. There is no power of this d by dx. So only single power 6. So this is 1 order and 1 degree of this equation. Question number 1 is now solved. Degree and order of the equation number 1. Question number 1 is 1 1. Both are 1 1. Okay. Each is 1 1. Let me take now. Both are 1 and each is 1. Now let me take second question. Now question number 2. Question number 2, this is here. Okay, question number 2 is, let me write second question number. D square y dx square is equal to 1 plus d by dx whole square whole power 3 by 2. Now what we have to do? If I square both these sides, okay, if I square both these sides, then let me take this way. Taking or squaring both sides, we get here d square by, this is squaring both sides. Squaring both sides, we get the solution here. Solution we are finding out. What we have to do? To square both the sides. This is whole square equal to now 1 plus this is d by dx whole square. Now this is whole cube. Okay. Now this d square by upon dx square, dx square, sorry, whole square is there. If I open this, for this d by dx whole square, whole cube we can open, but even then this second order derivative is this one. This is the highest order derivative. So the power of this is 2. So 2 is the degree here. Even if we open this, doesn't matter. Let me open this. This is 1 plus d by dx whole 6, because whole cube of this aq plus bq plus 3 into a into or a square into b, that means 3 into only d by dx whole square plus 3 into 1 into this whole square, that means this is d by dx whole 4. Try to understand. These are the 4 steps here. Whole cube of this will give us a plus b whole cube. That means a cube plus b cube plus 3a square b plus 3ab square. 3 a square means 1 square d by dx whole square as it is, plus 3 into the d by dx whole square, that means whole 4. Now in this case we have this double derivative, the second order derivative. This is the degree of this, power of this is the degree of the equation. Therefore now this equation is free from all the radicals or free from cube, etc. Radical, this is not radical here, this is whole cube powers exponents. Now in this part, in this case, this double second order derivative is the order of the differential equation. So the order of this differential equation, degree and order, let me write here. Order is 2 and degree is also 2. Why? Because this second order derivative is having power 2, degree is 2. Second, this is second order, but that differential equation is of second order. Why? Because this d by dx is the first order. The power of this first order we have not to consider. We have to consider the power or exponent of the highest order derivative. This is highest order derivative, second order. The power of this is known as degree. Got the point? This is question number 2. Now let us take question number 3. Okay, now let me talk about question number 3. What does question 3 say? Let me check it. So question number 3 is third question. X into d by dx in bracket. Okay, plus 2 upon d by dx. Now this is full of fraction. This 2 upon this is fraction. We have to make it first free from fraction. What we have to do? Take the LCM and cross multiply. Taking LCM, making it free from solution. First we have to make it free from the fraction. Now this 2 upon this is fraction. Make free. We have to take the LCM here. D by dx is the LCM. It will be x into d by dx when multiplied by d by dx will be whole square plus 2 equal to y square. Now cross multiply. After cross multiplication we will get d by dx into d by dx whole square plus 2 equal to y square into d by dx. D by dx will cross multiplied to y square. Okay. Now this is the equation here. This is a differential equation. So what is the order and degree? Now order is 1 order. What is the order of this equation and degree? Let me talk about degree and order. Order is 1 because this is single order derivative. Only d by dx is there, so this is 1 order. And the degree is 2 because highest power of the highest order derivative. Okay, the power of the highest order derivative means d by dx is whole square, so this is degree 2. We have to take the power of the highest order derivative or order of that differential equation. We know that order of the differential equation is the highest order derivative which is found in that. The order of that highest order derivative which is found in the differential equation is known as order of that differential equation. Now here is d by dx only. Single order derivative is highest order here. This is also d by dx, but this is d by dx whole square. The degree of this, power of this is the degree. Okay, so this is question number 3. What the point now? This third question. Let me take now fourth question. The question number 4. Let me check. What is question number 4 here? Question number 4. This is cube root. This is cube root of this is cube root. of d square by upon dx square, okay, equal to square root of d by dx. This is d by dx, the square root of d by dx. Only this is the question number 4 here. So q root of this, that means it implies that solution we are finding out. First we have to make it free from radicals. Now this is radical, and this is square root, this is q root. Or we can write here d square by upon dx square whole 1/3 power is equal to d by dx whole 1/2 power. Okay, if I first let me square it, then cube it. So squaring it, or we can just say that if I take multiply by 6 of 6 power, if I find 6 times square of this, okay, or 6th power of this, if I multiply by 6 power, then it will be free from radicals, because LCM of 3 and 2 is 6. So we have to multiply this by I mean make it 6 times. This is d square by dx square. If I make 6 upon 3, no problem. LCM we take of the radicals, the denominator of the radical sign, we take the LCM of them. We multiply by LCM. This is now d by dx whole power 6 by 2. So we multiply by 6, I mean make it 6 power of this. Okay, so after taking the LCM, we take this. Okay, so this is how you have to make it free from radical sign. Now this is 3 to 6, 2 3 is 6. Here d square by upon dx square is power 2 only. The square of this is d by dx whole power 3 now. Okay, so here now this is free from radicals. Powers are there, no problem. Now highest order derivative is this degree and order. Let me find out order and degree. Order of this is 2 order, second order. This is second order derivative found in highest order derivative. Second order is d square by dx square. Second order derivative is found. Highest order derivative is second order. Degree of this is 2. Degree is also 2. Why? Because power of the highest derivative, highest order derivative is known as degree. So this is degree. What the point? So this is now, we have done this now. So power and degree both are 2. Okay. Now let me write this. This is the answer here. Degree and order both are 2. Okay. This is question number 4 here. This is how we free the differential equation from radicals. Radicals means we take the LCM of the radicals. If radicals are multi-radical sign, even then take the LCM, multiply by that. Okay, radical by that LCM. After that, it will be free from radicals. Next question, 5th question. Question number 5 is now. Okay, this is question number 5. This is d by dx whole square. Whole square plus, again this is full of radical fraction. This is now fraction here, divided 1 upon d by dx is equal to 2. What we do, we take the LCM, multiply this. So take the solution here. First we have to make it free from fraction here. This is fraction, not radical fraction. This upon this fraction. So taking LCM here, this is d by dx LCM. This will be dy upon dx whole cube now, because this d by dx into this is upon 1 upon this. LCM of 1 and d by dx is d by dx. We multiply this d by dx whole square by d by dx, we will get d by dx whole cube plus sign. This is 1 here is equal to 2. Finally we get d by dx whole cube after cross multiplication. We can do twice in this 2 into d by dx, or we can further write it as d by dx whole cube minus 2 d by dx plus 1 equal to 0. This is the differential equation of order 1, and degree is 3 here for this d by dx. Order of this differential equation, degree order is 1, d by dx only, d by dx. First order derivative is found here. Okay, and the power of that highest derivative is 3, degree is 3. Okay, this is the answer here. Question number 5 we have done. Okay, now let me take question number 6. What is question number 6 say? Let me check it. Now question number 6 here. Now question number 6 here, or 6th question. Y is equal to, okay, this is y equal to x into dy dx equal to y plus a square root 1 plus, this is d by dx whole square, square root of 1 plus d by dx whole square. Okay, this is question number 6 here. 6 here. So 6th question is y equal to x into d by dx plus a into square root under the square root is 1 plus d by dx whole square. 1 plus d by dx whole square. Now we have to make it free from radical sign. Take this step by x d by dx to left hand side. D by minus x into d by dx. This is equal to a under root 1 plus d by dx whole square. Now squaring both sides, only then this square root will be cancelled out. This is half power here. Okay, so this square root will be cancelled out after squaring this whole. After squaring both sides, let me write here. Squaring both sides. Squaring both sides, we get here we get y minus x d by dx whole square is equal to a square, because square of a is a square. Now this is square root, which is half power. The square root means this is square root of, suppose x is there, it means x is 1.2. Half power is this. This is 1.2 power, radical 1.2. Okay, so this is square root. Square root means if it is q root, then 1.3. If it is nth root, 1.n. If it is fourth root, 1.4, etc. Okay, so this is second root here, 1.2 power. So after squaring this, if I square this, 2 to cancel out, only x will be there. This square root will be cancelled out. This is a square, because square of a, into only 1 plus d by dx whole square. Let me write this large bracket. Okay, this is now free from radical. If I square it, both the sides are square. Let me square it. It will be y square plus x square into d by dx whole square minus twice xy into d by dx. This is square of a minus b whole square. That means a square plus b square minus twice ab. So we could write this middle term a square minus twice ab plus b square. That in that way also we could write it. Okay, that is the standard form, proper form. This is middle term. This is third term. First one, no, first term, equal to now a square plus a square into d by dx whole square. We see here that d by dx whole square, this and this is common. We can take x square minus a square into d by dx whole square plus y square this, and minus all equal to this, or plus minus we can write this is minus 2xy d by dx is equal to a square here. Okay, so this is the differential equation. With the order of this differential equation, now this differential equation, this is free from radical sign now. Okay, free from radical sign. So order and degree now. So what's the order and degree of this equation? Now order is 1, d by dx, d by dx. Order is 1, but degree is 2. Why degree 2? Because this d by dx whole square is there. D by dx whole square So 2 is the degree here. The power of the highest derivative, highest order derivative is known as degree. This 2 is degree. Okay, this is question number 6. This term, sorry, here. Degree and order we have to find out. Okay, we are calculating order and degree, or finding degree and order of the given equations, given differential equations. Okay, there's a topic here today. So degree and order. Now question number 7. What is 7th question say? Let me check it. Question number 7 is, now d square by dx square is equal to this is 1 plus d by dx, okay, whole square, whole power 3 by 2. Now if I square it, squaring both sides, because this is 3 by 2 power, this 2 we have to remove, 1.2 in the denominator. If I square both the sides, then it will be only 3. Let me square it. Squaring both sides, squaring both sides, we get, this is solution we are doing, solution here. So squaring both sides, what do we get here? D square by dx square, this is whole square, is equal to only 1 plus now d by dx whole square, whole power 3 now. Why? For 3 by 2, if I square it, then 3 by 2 into 2 power, 2 to cancel out, only 3. So this is qth power, or third power. This is 2 power. Now squaring both sides, this will be 3 by 2 into 2, 2 to cancel out, powers are multiplied. In this case, when we are squaring that is squaring 3 by 2 into 2, 2 to cancel out, so only 3 power is left over. Now if I open this whole square, that doesn't matter, because the power of highest order derivative is this 2 only. This is d square by dx square whole square. This, even if I open this 1 plus d by dx, doesn't make any difference, because this is whole q now. Whole q if I open doesn't change the order and degree of this differential equation, because second order derivative is this. So this is first order. First order derivative, even if it is 6 power, doesn't matter. If you want to further simplify this, if one wants to further simplify this, then we can cube it, but that is not going to change the order.